Go language programming, chapter 6, unit 6. In this unit, we will cover reflection, the reflection.Type and reflect.Value. Analyze any method with reflection. So basically, let us explore Go language reflection in this unit. So reflection provides a mechanism to update variables and inspect their values at runtime. So their methods could be called. At the basic level, reflection is just a mechanism to examine the type and value pair stored inside an interface variable. There are two types in reflection package. Basically a type and value. So these two types give access to the contents of interface variable and two simple functions which are called reflect.Typeof and reflect.ValueOf. Now, we will see these functions in the following examples that we will cover in unit 6. So the reflection is an ability of a program to inspect variable and values at runtime and find the type. Okay, so that's what the reflection basically allow us to do. At all this happens all at runtime. Okay, so in Go language, reflection allows inspection of struct, interfaces, fields, and methods. Okay, all at runtime. You can inspect them at during runtime. So and we will or you will understand what exactly mean by inspect them. Okay, when we go through the examples. So program does not need to know the names of interface, fields, and methods at compile time. So basically, when you write a code, it really does, and once it compiles, it doesn't need to know the names of either one of these things. So basically, all this happens at runtime. So in the following program, type num is known at compile time, okay, because Go language is statically typed. Okay, so for that reason, this the type of variable num is known at compile time. So what does it actually statically type means? It means that every variable type is known and fixed at runtime. That's what the statically type means. So you probably have heard that the Go language is a statically typed language. So that is the reason that we call statically typed language, because all of these things are known at the compile time and they are fixed at the compile time. So in this example, basically what we have is package main and then import fmt package and then entry point function main, and then within the body of the entry point function we create a variable called num and initialize it with 10. So that means this variable num is going to be of integer type because we are doing the short declaration. And then within the print f, we are basically, or we are using a printf from the package, fmt package, and we are displaying the value and the type of this num. Okay, so that's what it is displaying. So the value will be 10 because it was initialized to 10, and once we initialize the num to 10, the num was the type was created for num as integer type. So that's why you see int. Okay, now in this case, of course, we are not using the reflect function, but reflect or the reflect package. We are not using it, but reflect package is really actually used within this FMT package. Okay, and that's how this format specifier can tell what type this variable is, the num. Okay, so reflect package is used within the format package, from this printf function. So let's look at another example, which will go over about the structs. So the structs that give access to the metadata of a running program are in the reflect package. So basically, reflection is supported by following functions in reflect package. So uh, reflect is a package name that is in the standard Go library, and within that package we have the function type and value, and also we have a kind, so we can find out the kind, and we can also use the num field, basically number of fields from the struct, and the methods that are attached to the struct, and then this function int and string methods also are within the reflect package. Okay, and we'll see all these in action in the following examples. The reflection package implements a runtime reflection that allows a program to manipulate objects with arbitrary types. Okay, so basically, at runtime, some arbitrary types your program is running, because of the reflection package. So the typical use is to take a value with a static type, which is type interface, and extract its dynamic type information by calling TypeOf, which returns its type. So basically, when you do that, the interface, for example, can hold any type. That means it can hold any concrete type. So the type of will give us whatever the type was passed to the interface, and it will give us the concrete type. Okay, that's what the type of will do. So the signature of reflect.TypeOf includes an empty interface. So this is the signature. This is the signature for that type of function, which is in the reflect package. Okay, so it is taking the parameter of type interface, and then it is returning the type of whatever the type of that parameter is. If it's an integer type, it will return the integer type. If it's a float, 64, it will return that. So a call to a value of returns a value of representing the runtime data. So when you use a value of, that means it will be giving you the data for that particular type, okay, that has been identified. So we'll see that in this example. Okay, so we go over this 6-19 example, which is basically a compiled code. So we are including or using the package main, and then we import these two package, fmt and reflect package. Okay, that's a standard library package that we are importing. And then within the main entry point function, very first thing what we are doing at line number 9 is creating a variable called x of type float 64 and initializing with some data. And then at line number 10, we are using a reflect package, okay, and from that reflect package, we are using a type of on the variable that we created, okay, which is a float type, okay. So we are passing that variable now. As you can see, this, since we are passing a float 64 or float 64, so if you go and see the signature of type of right here, when it comes to this parameter, it will automatically will know that this is 64, float 64 type. Okay, so this function will return 64, float 64, sorry. It will return float 64 because of this signature, that is telling us. And then at line number 11, we are saying that reflect dot value of x dot string. Okay, so we basically are trying to get the value, but it's not the string. So basically, we are, it is just simply saying is a value is 64. It is, we are um, not we are not reading the data. We are just reading the type information. Okay. So right here in the next slide, what we are going to be doing is to use this reflect type and reflect value from this package. Okay. And as we just discussed, type of is the one which basically returns the reflex type, and value of which will return the reflect value. Okay, so the reflect package implements a runtime reflection in Go language. So all this thing is happening at runtime. The two functions that we just went over, reflect.Typeof and reflect.ValueOf, which returns the actually type and the value. Okay, so that's what we're going to go and see in this example. In this example, what we have, since it's a going to be executable. So we have the package main, and then we have imported this reflect package along with the fmt package, and then we create an employee struct. Okay, so we are creating an employee struct, and within the employee struct we have three fields: the first name, the last name, and the age. So first name and last name are string type, and then the age. Now, right after that, what we have, these are called the tick mark. They are actually above your tab key. Okay, these are not single quotes. These are the tick marks. So within the tick mark, what we have is this tag underscore name. Okay, and we are saying that instead of having this name right here, first name, we are changing the field name to E name, for example. For the last name, instead of a last name, we are changing it to L name. And for this capital A, we are changing it to the small a, okay, H. So basically, that's what the tag allows us to do, to change the names. Whatever the name that I want to give, I can change it right here, okay, and not use the field name itself within my code, okay, or when this instance is basically created for this employee struct. And then we have a method. This is a method because it has a receiver, okay, and the method name is check reflect, okay, that's what the method name is. And within this body of this method, what we are doing at line number 14, we are using a reflect package, and from that package we are using a value of uh, basically value of what, value of this struct, okay, dot element, so each element that we want to be able to access. So the element will be initialized to this value, whatever the element is going to be. Now what we will uh, uh, go through is to, by using this VAL, we will go through each name in the struct, okay, and that's why we have this for loop right here. So in the for loop, what we are finding it out is value dot number of fields, okay, number of fields in this struct. So that's what we will get, number of fields in the employee struct, and then find out each field value, okay, that's what this val dot field, it is going to go through, index through each one of them and give us actual field value, okay, and then the type, what type of that field is. So that's why we have this value dot type dot field, exact field number, okay, and then tag name. Tag, as we just discussed, would be the new name for the field. So that's what we are initializing this tag with, tag dot, I mean, type field dot tag. Okay, so type field is coming from line number 18 right here. Okay, so it will give us the field type, and from that we get the tag. So when I do the use a printf within this check reflect function, or the method, we can get the field name, the field value, and tag value, okay, all of these we can get it because we have a type field, a value field, and tag, which we did it right here, within the for loop body. So each time that it goes through the for loop, it will pick up the actual fields from this struct, employee struct. Okay, so in the main, or in the entry point function, what we are doing is basically creating an instance of employee type, and and getting the address of that instance and putting it in the EMP. So EMP will be a pointer. to the struct. Okay, so that's what the EMP is going to be, because we are putting the address into this variable. And then at the same time, we are initializing these fields in the struct. So basically, first name Patrick, last name Stewart, and then age 80. Okay, so basically it is going to initialize with all this data. This struct will be initialized with all the data, and then we are using this pointer type variable to call this check reflect um, uh, you know method. So notice that this is EMP is a pointer type. So in this case we do not need to do the dereferencing, because Go language automatically does it for us, even though it is a pointer type. So it will end up calling this check reflect method. Okay, and of course it will pass the address of wherever the memory was allocated for this employee to this check reflect method. Okay, and that's how it will find out more information, this within the body of this within the body of this method. It will find out more information where the because of the address that was passed to this method. So the output looks basically, each time the for loop goes through, it will find out the name of the field in the struct, and then the field value, meaning the data. Okay, and then the tag value, which is the shorter name for the field. Okay, and it will just do the printing of um, from within the check reflect method. Okay, so as you can see, that reflect package is pretty powerful. It allows you to get the specific types and the data at runtime. It is all done at runtime. Okay, so let's in the next slide we will go and analyze any method with reflection. Now this one is basically little involved, and it goes into much more detail. Okay, so here what we have is Go does not have an intuitive way of retrieving function names, but method names can be retrieved by their names. Okay, now so to retrieve the method names, we can use a reflect package. Okay, and once we do that, then we know which method was used. Okay, and that's what basically in this example that you will see. But as this bullet says, that you cannot really retrieve the function name, but you can retrieve the method names. Okay, so that means we are using the method in this example, which is attached, which this method is going to be attached to the employee struct. Okay, so let's go over the code. So at example 6-21, we have a package main, and then we import FMT reflect package and str convert. So basically what this package will allow us to do is to use this function which will do the I to A, to integer to ASCII. So that's what this package will allow it to do. It will convert from integer to ASCII. So it takes the integer number and it will convert it to ASCII value. Okay. So we have empty struct at line number 8 of employee, name employee. And then we have at line number 11, we have a method, say hello, okay, which is attached to the employee. Okay, and as you can see, the receiver is taking a pointer type parameter. This is the receiver which is taking the pointer type parameter, and hello, say hello method is taking the regular parameter. So in this regular parameter, it has the very first one is a string type, second one is an integer type, the third one is a struct type worker. Okay, and then it is returning this bool type. Okay, either true or false. So that's what it is returning. So now we have a function called um, function analyze, okay, which is taking the parameter of type interface, as you can see. So whenever you have a parameter of type interface to either to a function or methods like this, with the empty curly braces, that means you can pass any type you want to any type of a parameter that you like. Okay, the only you have the responsibility is within the body of this method or a function. You need to be able to basically take care of the whatever the type that you are interested in. So what I'm trying to say is that you probably should be using in this kind of a logic, you should be using um, uh, a switch statement, type switch that we covered, I believe, in the last in lecture or in chapter 5. Okay, type switch. So that type switch will tell us what type is passed to this function. So we will have it in there. But in this function, function analyze doesn't have a type switch, because this code basically, when it makes a call to this function analyze, it will only pass the method name, which will be this guy right here. Okay, so that's why it is not using the type switch within the body, because that's the only thing that it will always have. Okay, so here when we go inside the body, the line number 16, the comment says reflection type of the underlying data of the interface. Okay, so that's what the type of, so when we do the type of in this case, we are doing the type of on the m is a parameter, so we'll find out the type of that will retrieve the reflect type. X holds the type, so basically it will give us the type, what type it is. So in this case, since we are going to be only passing the method, so it will be the method type. So this will be a method. And then when we do this print right here, which will basically value of, it will print this value of x. So let's see the output right here. So value of x, so it is actually, it is giving us the method name. This is the method that it is holding, so basically that's what it will be printing. And x x is going to be type of x is going to be this pointer to our type, which is so this will be x will be holding the address. Okay, so and then if we go back to here and see, um, in here we at line number 20 and 21, what we are doing is trying to find out how many parameters were coming in, so inbound and outbound parameters. So inbound parameter will be 3 and outbound will be 0. Okay, there are no parameters that will be going out. So basically, in this case, the output that I was just showing it to you, it will show the name of the method, okay, which will be the same as this x is holding, and then variadic function that it will find out that is this method that so in this case, this we are talking about, so say hello, is the say hello is a variadic. Remember the definition of variadic, meaning it will take any number of parameters. Well, this is not the variadic function. So in here you will have the output of this print line will be false. Okay, because it's not a variadic. This say hello is not variadic. So we'll see the output in a second. And package, the path. If it knows the path, then it will print. If it doesn't know the path, not necessarily always it will know the path where the package is located. So it will be just empty, but if it knows the path, then it will print that. So let's look at that output for up till that line. So in this case, we just went over these three outputs. Method, which we know that it is going to be the say hello method, and then it is not a variadic, so that's why it is giving the false. And the package, it doesn't know where this package is, so that's why it is just empty. Okay, and then uh, it is going to come to line number 27, and it will print out this before num in for loop. So num in is what? Num in is coming from this, how many parameters are in, so basically in this case, it is going to come to this for loop. Num in is going to be 3 parameters, so it is going to go 3 times, okay, in this for loop. So here what x dot in returns a pointer to type value. So basically, this in v is going to be holding the address, okay, and that's what it will be holding. And then we have a this kind in v kind, what kind it is, and so let's look at the output for that. Uh, so we are right here. So in v kind, so it is going to be a string, okay, and then in v is a string. So basically kind in v dot kind, and this in v, which we were we were going over right here, in v, which is in v kind, and in v by itself is basically coming from here. So they both, so this inv and inv.kind, they both are the same type. They both are telling us that it's a string. Okay, and if we go to the output again here, and then uh, x dot in, which is going to be a pointer. It will give us the address. Um, so that's what it is going to print. And then parameter in start with the 0. So first parameter, and then this is a second parameter, and this is a third parameter. So there are three parameters in this function. So as you can see, 1, 2, and 3. These are the three parameters, and that's why. So the first one starts with a 0, and then the int is 1, and then 2 is this main dot employee. Okay, that's the parameter that it takes. This function. So this is employee type parameter. So it is going to go and print out these parameters and the numbers that I was just pointing it out, 0, 1, 2. It is because it is converting integer to ASCII, by using this package strconv. Okay, and it is printing it out as a string basically. Okay, and then it is also giving us the name of the parameters. Okay, and then it comes to the uh, outnum. Outnum will be 0, as you can see that um, the output, right here. So it does, there is no parameter going out. Okay, it is only taking the parameters in. So that's why it is 0. Okay, and uh, so it is printing out right here. So so this um, it is going from 0 to, this is just num out. It's just 1 only. So that's why it is just going to go only one time in this for loop. Okay, so that's basically about it for this example, and that concludes unit 6, chapter 6.